Hello everyone and welcome to the course The Web as an Application Platform or 1DV027. My name is Arslan Musaddiq and I am one of the teachers for this course. I am part of the Faculty of Technology in the Department of Computer Science and Media Technology here at Linnaeus University. You can reach me at my email address here and feel free to contact me if you have any questions about the course or the material we will cover. In today's lecture, I will I will be starting with an introduction to the Internet of Things or IoT in short. This topic is critical because it combines key elements of technology, web development, networking, and real world applications. So in this lecture, I will go through the foundation for understanding IoT. We will discuss its core concept, explore example of IoT system, and by the end of today's session, you should have a clear understanding of what IoT is. So let's get started with this lecture. So I will go through the general overview of IoT system. Here, first of all, as we know, we have a device that consists of sensors and microcontroller. It refers to the physical layer of the system. Microcontroller, or maybe it's better to call it a development board. This device is collecting data from the environment. For example, it could be a temperature sensor or motion detector or any other sensor. And then this device is sending those messages or data to the gateway. Gateway is collecting data from the sensors and then transmitting it to the network layer. This communication between device and gateway is happening with the help of number of communication technologies options that we have. For example, Wi-Fi, Bluetooth, LoRa, LTE, or Sigfox. In this lecture, I'm not going into the detail of these technologies because then it's a subject on its own, and then it is out of scope of our lecture. So now just assume that we have a device that consists of sensors and a development board. It is sending data to the gateway using a communication technology. And then gateway is connected with a network layer or network server, which is responsible for handling the data transmitted by this gateway. Gateway is like a bridge. It acts as a bridge between this device and the network server. And network server is doing data routing, connectivity, authentication, all the functionalities what network layer is doing. How these things are happening, how data routing is happening, authentication is happening, I'm not going also in that detail. Then after this, we have a cloud platform where data is stored, processed, and analyzed. It provides the computational power required for processing large data set. And then finally, we have a uh, client here, but here you can see we can have another gateway. It's an optional gateway in case if you are sending data to another IoT systems. Anyways, at the end, we have a client, which is the user interface. Client uses mobile or web application to interact with the IoT system. So this architecture illustrate the path of data from physical device to user application. You can see here the flow IoT. We have a IoT device, then it is sending to the gateway is sending to network server, and then we have a cloud platform that includes a back end and maybe front end, and then we have a mobile application. Now look at here again, consider that we have devices. In this case, let's take an example that we have CO2 and total volatile organic compound sensor. These two sensors are collecting data from the environment and sending it to the gateway, which is Wi-Fi based. And then we have something called MQTT broker. MQTT broker is an application server that collects data from these devices, and then the clients subscribe to this broker, and then every time this device has a data, it will publish to this MQTT broker, and on the other side clients will receive this data. This is how MQTT broker and client architecture looks like. I added this image here. We have clients, these are publishing sensor data, and they are sending this information to the broker here. And on the other side, we have clients, and they are subscribed to this topic, for example, temperature, and they are receiving this information. So every time this device has the data, it will publish it to the broker. So just like previously, I showed you, we from gateway, it's a network server. So here we have MQTT broker. It's an application program like a server program. Uh, Anyways, then we have clients here which are subscribed to this MQTT broker, and then we have mobile application. So now imagine this, that this part is done, this part is done, this part is done. We have a research engineer, Andreas, who completed this part, and now this is where you are, you will be doing things in this course. So consider that you are receiving messages, IoT messages or IoT data. Here you are a client, and then your task is to create a mobile app or web app or make sense out of this data. So this will be your part, right? And in this IoT part, we are giving this as an assignment for you. So I hope you understand. If you are not sure about what MQTT is, in the next coming lectures, we will cover more about this. But for now, just to give you an idea, this is how the flow is, and this is where you will do your assignment. This part you will be covering. So now let's dive more into our topic. What exactly is IoT? What is the definition? Simply put, IoT refers to the network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enable these objects to collect and exchange data. This is the exact definition of what is IoT. To give you an example, consider devices like smart watches, smart thermostats, or even smart refrigerators. These devices use embedded sensors to collect data such as your heart rate, room temperature, or inventory of groceries, for example, and then transmit that data over a network for further analysis or actions, as you saw in the previous slide. So the potential of IoT is enormous. According to the report from Statista, the number of IoT connection worldwide is expected to grow significantly, as you can see in this graph, between 2022 and 2033. This indicate not just the rapid adoption of IoT, but also its increasing importance in our daily lives and various industries. So understanding this fundamental definition is key as we explore the broader applications, challenges, and opportunities IoT presents. Now, this next slide is also providing the conceptual view of IoT system that I have explained in the previous slide. But from here, you will get more idea, more understanding how this system is working. As you can see, we have IoT end devices. There are a number of sensors, and these sensors are connected with the gateway using any communication technologies that we have. And then it is connected with the cloud server where data is stored, processed, or analyzed. And then this data, on top of that, we are creating IoT applications. Now, let's talk about the devices themselves. As we discussed, IoT devices are essentially embedded computers equipped with sensors and actuators. These sensors are responsible for collecting data from the surrounding, as we know. while actuators perform specific action based on that data. So these devices are designed with connectivity in mind. So we have a radio module here. Maybe this module can be built either directly onto the chip, or we can add it as an external module. And this is, one of the most important aspects of IoT devices, because we need a communication to make it to make it possible to exchange data and to do processing and so on. One defining feature of these devices is the use of microcontrollers, or MCUs in short, which are, as we know, compact processors, and they have constrained resources. These microcontrollers typically have a small, slow processor, limited memory, and are optimized for low power consumption. Because they are consuming low power, making, this kind of design is making them ideal for IoT use cases where efficiency and cost effectiveness are essential. And we know many IoT devices are powered by batteries. Some even use energy harvesting techniques to sustain themselves, for example, solar panels and so on. This energy efficiency is also critical to ensure the long-term viability of IoT deployments, because often they are deployed in a remote and harsh environments. So if I summarize, IoT devices are compact, resource efficient, and they are collecting data and sending it using our communication, low powered communication technologies. Now let's talk about sensors. Uh, we are aware, many of us are aware what sensors are, but let's go through it. Sensor is a device designed to detect and measure changes in its environment. These changes could include factors like temperature, pressure, light, motion, and many others. So the principle is the sensor takes these physical changes known as analog signals and converts them into an electrical signal that can be processed, transmitted, or acted upon by the system. For example, if we take temperature sensor example, in a smart thermostat it measures the ambient temperature and sends the data as an electrical signal to the system. Similarly, motion sensor detects the movement, and light sensor measure the intensity of light in a room. Here you can see some sensors images. Some common example of sensors used in IoT are temperature sensor, sound sensor, light sensors, or distance or motion sensor. you know Overall, you can consider these sensors as the eyes and ears of IoT system, enabling them to perceive and respond to the environment. Without these sensors, IoT devices would not be able to interact with the physical world effectively. And here you can see some common IoT and electronic prototyping sensors. If you search on internet, you will find hundreds of them. This is how they looks like. And why I'm showing them here, to give you an idea how, sensors specifically for educational projects, prototyping, or if you have any hobby related to developing IoT applications, you can go for these kind of sensors. You can program them and you can, you know, run them according to your application. Yeah. And these sensors needs a development board to work. And here you can see some of the most popular development boards used in many educational IoT projects, especially. These boards serves as the foundation for building and testing IoT devices, providing the necessary hardware and interfaces for sensors, actuator, and connectivity modules. You can see these images. We have Arduino boards, Raspberry Pi, ESP32 or 8266, it is very commonly used. Each of these boards comes with its own strengths depending on the requirement of your project, whether it's cost, processing power, connectivity, or ease of use. And these are some of the commercial sensors. I pasted, here these images just to give you an idea how commercial sensors looks like, because in the industry we want more accurate, reliable, and efficient sensors, and we want them, like just we just install them and they must be up and running. So they are little bit expensive, but often more accurate and more efficient. Yeah, and here another key component of IoT systems is actuator. It is the device that performs physical actions or movement in response to external signals or commands. These commands typically comes from a control system, or or maybe they are based on sensor data. Essentially, while sensors gather information about the environment, actuator allow IoT systems to interact with and affect that environment. Actuators works by converting electrical or digital signals into physical actions. This is the opposite of what sensors do, which convert physical changes into electrical signals. For example, an actuator can open or close a valve to regulate the flow of water or gas. It can move a motor to adjust the position of a robotic arm. It can turn a switch on or off, controlling lights or other devices. And here we have some images of the most common examples of actuators that includes servo motor, LEDs, relays, or step motors. Actuators play a vital role in enabling IoT systems to make meaningful actions in the real world, making them truly interactive and functional. And next, we have gateways. As we saw before, gateway serves as the bridge between local devices and networks on the internet. It ensures that data collected by IoT devices can be transmitted to the cloud or other remote systems for processing, storage, and analysis. Gateway performs two main roles. One, transparent gateways, this just simply forward data without any modification. Or maybe we have a payload converting gateways. They are more advanced and can modify or convert the payloads. For example, they may translate data format or protocols so that the receiving system can properly interpret the information. The choice of gateway depends on the use case. For simple system, a transparent gateway may be sufficient. But for complex IoT systems involving multiple protocol or many devices, payload converting gateways may be required. So another role of gateway is to provide the security by managing data encryption and monitoring the traffic. Some gateways even include processing capabilities, which allow them to filter or pre-process data before forwarding it. So it reduces the load on the cloud. In short, you can consider gateways as the backbone of connectivity in IoT systems. And here you can see you can have a Wi-Fi based gateway or LoRaWAN based gateway. What is LoRaWAN? It's a communication technologies that uses sub 1 gigahertz communication frequency. You can have a gateway specifically designed for outdoor installation, or maybe you can have an indoor gateway as well. Here, let's look at an example of a gateway used in IoT. It's called the Pi-Gate gateway. It's a compact LoRa gateway developed by a company called Picom. It supports two regional frequency bands, making it adaptable for use in different parts of the world. For example, 868 megahertz is commonly used in Europe, whereas 915 is widely used in United States and other regions with similar regulatory requirements. It's a great example of a lightweight IoT gateway designed for LoRa-based communication network. So this specific example shows how gateway like the Pi-gate enable IoT devices to operate rapidly across global networks. It can provide a perfect solution for agriculture, logistic, or environmental monitoring. As we discussed before, that connectivity is one of the most critical components of an IoT system. It enables devices to communicate with each other and with the cloud. So depending on the use case, there are several connectivity options to choose from, each with its own strengths and limitation. For example, now we have Wi-Fi 6, Wi-Fi 7, fifth generation based new radio, or LoRaWAN, Zigbee, many others. Each of these connectivity options is tailored to specific IoT requirements such as power consumption, range, and data throughput. Choosing the right options depend on the specific application and constraints of your IoT system. As I mentioned before, that these connectivity options provides different speed, range, or battery power consumptions. For example, here you can see in the blue, we have Wi-Fi, Bluetooth, and Zigbee. They provide shorter range but higher speed. And since it is providing higher speed, it consumes more battery power. On the other hand, here we have LoRaWAN based communication technologies such as LTE-M, NB-IoT, or Sigfox. It offers long range, also consumes low battery, but the speed is often low, suitable for IoT based applications. And similarly, we have cellular network such as LTE or 5G. It consumes more power, provides high speed, and also offers long range. Which communication technology to use? It depends on your specific IoT application or project needs. Uh, Layering model, TCP/IP. I added this information here because to understand how IoT devices communicate, we need to discuss TCP/IP network stack and its layer. What is TCP/IP? It stands for Transmission Control Protocol slash IP or Internet Protocol. It is a set of communication rules or protocols, you can say, used to interconnect devices over a network, such as the Internet. TCP/IP is the foundation of the internet and most local networks, enabling the reliable transmission of data across diverse devices and systems. So these layers also provides the foundation for IoT networks communication and ensures seamless data transmission. For example, for the first layer, we have application layer. Application is where user interaction and data processing occurs. In IoT, it includes protocols like HTTP, MQTT, or CoAP. How these protocols works, or what are the rules and principles behind these protocols, we are not going into that detail. But just to give you an idea that IoT communication is also happening like a layered wise TCP/IP communications. The difference is that there are different protocols because we need to handle the constrained resources of the devices. For example, at transport layer in IoT, we mainly use UDP. If you are not aware of UDP, just consider it for now as that it is a protocol where we don't need acknowledgements or we don't need to create a connection. It consumes less power, it is fast, and so on. Similarly, we have different protocols for network layer, because in a traditional TCP/IP network layer, we have a very heavy protocols that are unable to run on on a small IoT devices. For example, RPL, routing protocol for low power and low C IoT devices, is one of the examples of compact small routing protocol for these devices. And then we have a physical and data link layer where you know it it consists of technologies like Wi-Fi, Ethernet, cellular, or Zigbee, LoRaWAN, and so on. And here now, let's take a look at some of the key applications of IoT across various sectors. You know, IoT is transforming industries by enabling smarter or more efficient systems that are automated and data driven. Here are some major IoT applications. There are many modes, but I mentioned these here. Smart home automation, very common. IoT is playing a significant role in energy management, lighting, and security. Devices like smart thermostat, lighting system, and security cameras can be controlled remotely. And now we have commercial devices available. You can just buy them, and they will be up and running. In healthcare also, IoT is, we have applications like remote patient monitoring and fitness tracking. We have devices like smartwatches or devices to track the vital signs like heart rate, temperature, and many, many more. In agriculture, we have precision farming. It is now possible with IoT sensors that monitor soil conditions, weather, or crop health. We have application in transportation industry also, for example, fleet management or real-time data management and so on, routing, monitoring vehicle health, or improving, overall improving the logistic. In many other industries, we have number of sensors to predict the machine failures or monitor the machine or overall operation and so on. In retail, we have smart inventory management or customer analytics. Environment also, there are tons of applications. We have smart classroom, remote learning system in education as well. Now, to inspire you, I will show you some examples from summer 2024 applied IoT course. Last year in summer, we had this course where several interesting IoT projects were developed. I will show you, let's take a look at some of the examples to get a better sense of how IoT can be applied at various real world scenarios. Here, there was a project, Dog Activity Monitor. You know, the student used number of IoT sensors to track the movement of dog, sleep pattern, or overall activity. This data was then used to provide insight into the dog health and well-being. This is aging dog, so it's the owner of the dog, Simone. He utilized IoT to monitor the health of his dog. Another example was plant monitoring system in home or office setting. The IoT sensors measured key factors like soil, moisture, temperature, and light level, sending real-time data to an app. So this allowed user to receive alert when their plant needed attention. Another fun project was Smart Sangria Pump. This project used IoT technology to automate the process of dispensing and mixing sangria with sensor, measuring the proportion of wine, fruits, and spirits. The system allows user to remotely control the pump via an app. So it was quite a fun to see this pump in action. And then another practical example was water well monitoring. They used a water level sensor to measure the level, pressure, or flow in the well, and then remotely the user can see blockage or low water levels and so on. These examples demonstrate the versatility and impact of IoT in variety of applications from pet care to home automation or even smart beverage preparation. The possibilities are vast and the future of IoT offer exciting opportunities for innovation. So it's good that you learn it, and maybe even if you are not doing anything commercial, you can solve your problems that are happening in your surroundings, such as these projects. And here, let's take a look at previous IoT projects that we did in collaboration with small and medium sized companies in the region. These projects are a great example of how IoT can be applied to improve, operational efficiency or better decision making. For example, here you can see this theme park. We installed number of sensors, temperature and humidity sensors in the cabins. We installed visitor counter and we created a dashboard for easier monitoring and alarm in case of abnormal values. Simple IoT sensors, they are used to enhance the efficiency of this theme park. And another great example is this project. We collaborated with a company called Oland's Shocksmiri. It's a cheese factory, and this cheese factory wanted to automate and improve the cheese production process using IoT technology. So the primary goal was to automate the pasteurization process, which, as you know, is crucial step in cheese production. So by integrating IoT devices, we aim to ensure that this process is carried out consistently with precise control over temperature and other parameters. So it was one of the best examples that I can show you here. And here I can show you another example. It's a restaurant here in Kalmar. They wanted to measure the number of visits, noise level, temperature, and humidity inside the restaurant. And then they wanted to store this data, visualize the data to get better view of the environment. So we installed all those sensors, and this restaurant was kind of digitalized. So uh, that brings us to the end of today's lecture on Internet of Things and its key component. From devices and sensors to connectivity and applications, as we have discussed, IoT is transforming a web variety of industry, offering new opportunities for automation, efficiency, and innovation. The concept we have covered today are fundamental for understanding how IoT networks function and how they are applied in real world scenarios like smart home, healthcare, agriculture, or manufacturing. Remember that IoT is constantly evolving, and as we move forward, new technologies and strategies will continue to shape how we interact with the world around us. Uh, I encourage you to review the materials we discussed today and start thinking how you can use these concepts if you want to develop an IoT project or if you want to conduct a research on this topic. As always, if you have any question or need further clarification, feel free to reach out to me via email. Before I finish, I would like to recommend some books. Here you can see these books can help you to delve deeper into IoT concept and practical applications. These readings will help you explore the subject further and provide valuable insight into the fields. And of course, you can find more materials on the internet. I hope these resources will enhance your understanding of IoT and its many applications. Thank you for your attention, and I look forward to our next lecture.